Hello, this will be a demonstration of proposition 26 from book 3 of Euclid's Elements, which states that in equal circles, equal angles will stand on equal arcs, whether the angles be at the center or on the circumference. What this means is that we are given two equal circles, A, B, C, and the circle D, E, F, and these two circles are equal. We are also given their centers, the point G and the point H, respectively. And we have it such that the angle BGC is equal to the angle EHF, and the angle BAC is equal to the angle DEF, so. And if all of this is the case, that these angles here, standing on these arcs, be equal, then the arcs on which they stand will be equal. In this case, these are the arcs BKC and ELF, right? So these angles here stand in the arc BKC, and these angles here stand in the arc ELF. And we've set out to prove that the arc BKC is equal to the arc ELF. We begin by joining the straight lines BC and EF. We can do that easily by postulate 1. Now we know that the straight line BG is equal to the straight line EH, and furthermore that the straight line GC is equal to the straight line EHF. We know this by definition 3.1. These are radii in equal circles, and the radii in equal circles are equal. So we know that BG is equal to EH, and GC is equal to HF. And we know that the angles contained by these equal straight lines are equal as well, namely that the angle BGC is equal to the angle AEHF. And if in two triangles we have two sides equal to two sides, and the angles contained by the equal sides equal as well, the triangles will be equal in all respects. That's proposition 1.4. The important respect here is that BC is equal to EF. Now if we consider the segment BAC, or the segments BAC and EDF, the angles in these segments are equal. And so by definition 3.11, we know that these segments must be similar. So the segment BAC is similar to the segment EDF. And these two segments are on equal straight lines, right? We've just shown that BC is equal to EF. And similar segments on equal straight lines are equal to each other. And so the segment BAC is equal to the segment EDF. It's proposition 3.24. We also know that the whole circle ABC is equal to the whole circle DEF that was given to us. And so if we subtract from the whole circles these equal segments, so we subtract the segment BAC from the circle BAC, and we subtract the segment EDF from the circle DEF, what we are left with is the arc BKC and the arc ELF. And when we subtract equals from equals, the remainders must be equal. That's common notion 3. And so the remaining arcs BKC and ELF must be equal to each other. This being what we set out to prove, we are done with the proposition, therefore, etc. QED. Now, it should be noted that this proposition quite obviously works if these angles are actually in the same circle. So if we have a case like this, we're at the center, we have equal angles, maybe something like that. So if these angles are equal, we know that these arcs must also be equal. That's III.26 again. This proposition works if the circles are simply the same circle. That being all I have to say about this proposition, I will end the video here and move on to III.27.